So in this session, we are going to look at how to combine functions. We are going to look at a few worked examples relating to functions, how to combine them. So let's get started with number 1. We have f of x being giving us as 3x squared minus 2x plus 4. They're telling us find f where the input is negative 2. In other words, they're trying us to find the value of the function or the value of y when x is negative 2. So we go ahead and substitute in there. It's going to be 3, the function is 3x minus 2x plus 4. So when x is negative 2, it means it's going to be 3 times negative 2 squared minus 2 times x minus 2 times negative 2 plus 4. This is going to become 3 times, negative 2 squared is 4. So it's 3 times 4 minus, okay, this is negative 2 times negative 2, which is positive 4. So we shall simply say plus 4, then plus 4. So 3 times 4 is 12 plus 4 plus 4 is 8. 12 plus 8, the answer is 20. So our answer is E. So if f of x is going to be equal to 4x minus 5 and g of x is 3 to the power x, then find f g of 2. So this is a composite function. Let's first find the function inside g of 2. So meaning that g of 2 is giving us, first of all, we know g of x to begin with. G of x is giving us 3 to the power x right there. So it means that g of 2, so when the value of x is 2, is going to be giving us 3 to the power x. In this case, x is 2. So this is going to be 3 times 3, which is 9. So if the g of 2 is 9, it means that this function is going to become f of g of 2. Our g of 2 is 9, so it's f of 9. So what is the function when the value of x is 9? First of all, f of x is 4x minus 5, yeah? So it means that if f of x is going to be 4x minus 5, so f of 9, so in the place of x there is a 9, so it means that where there is x we put 9, it's going to become 4 times 9 minus 5. It's going to become 4 times 9 is 36, so it's going to become 36 minus 5. 36 minus 5 gives us 31. So the answer is D. And then we have this number. If f of this composite function is given by 4x squared minus 8x and f of x is x squared minus 4, then what is g of x? So we have been given f of x. If you look at this question, this is f of x. This has been given. F of x is x squared minus 4. And according to this expression, f of x giving us x squared minus 4, the value in the function, the input for f in this case was another function that we are calling g of x. So the question is that what is this function g of x? I may approach this in 2 ways. Let's look at the first way. So well, we can go ahead and get these answers a, b, c, d, e, and try and plug them into here, because these are possible functions of g of x, the g of x we are looking for. So we are going to plug in a right there, or b in there, then we plug in c in there, then we plug in d right there, or we plug in e right there, and then we see that if we plug in this function g of x in the place of x in this expression, do we get this expression? A number that gives us this expression, when we plug this in here, will be the answer. So let's get started. So let's begin with a. A is 4 minus x. We know that f of x is going to be x squared minus 4. So if 4 minus x is given right there, so this is going to become f of 4 minus x is going to give us 4 minus x minus 4. This is squared. So this is going to become, of course, this is the whole value of x. This is the input, actually, the input. So that's the input right there. So this is going to become, of course, 4 squared is 16 minus 8x plus x squared minus 4. And this is going to become x squared minus 8x Then 16 minus 4 is 12 plus 12. Now this expression is not that, so it means that A is out. Of course, if we go to B, part B, if we put X, part B, plugging in X here is simply going to still give us, putting X there, it's going to simply give us X minus 4. So B is out of the picture. Let's try C, 2X minus 2. If we put 2X minus 2 in the brackets here as our input for this expression, is it going to give us that? So we try. It's going to be, this becomes F of 2x minus 2 is giving us x squared. In this case, it's going to be 2x minus 2. This whole thing is squared minus 4. This is going to become, expanding this is giving us 4x squared minus 8x plus 4 minus 4. Of course, this is going to become 4x squared minus 8x. And if you look at this 4x squared minus 8 is consistent with this 4x squared minus 8. In this case, the answer here is C. So the question again, if this is equal to that and this is equal to that, this composite function, it means that the g of x is going to be 2x minus 2. In other words, if our function of f is such that the value of x here is the function, and which function is 2x minus 2, if we plug in 2x minus 2 there, then our output is going to be that. So that was one way of doing this. Now, what if they gave us this very same number, and what if they didn't give us these answers and we were supposed to just find it the way it is? How would we go about that? So this is an alternative way of looking at this. We have this composite function f into g of x is giving us 4x squared minus 8x, and f of x is giving us x squared minus 4. So what is g of x? Now, to begin with, this is a composite function. We are having the function g of x inside f. So we shall start with this. We have f of x is giving us x squared minus 4. That is the original function. But now, what happened? Let's substitute in the value of g of x in this expression, because it is a function where the input is another function, g, where the input is also x. So in this case, this means that if we put f, the function f in brackets where the value of x, now the input has become g of x, this makes this function to become g of x, where there is x is where you put g of x. So it becomes g of x, this is squared minus 4. So what is the function where f of g of x is this expression? F of g of x, this composite function, is given by 4x squared minus 8x. So that is exactly what we go ahead and do. We go substitute this here. We say that 4x squared minus 8x is giving us this expression. G into x, all this is squared minus 4. So what we do here, we go ahead and solve this, and we make g of x the subject of the formula, and we will be able to get our answer as required by the question. So this is going to give us 4x squared minus 8x. This 4 comes this way, it becomes plus 4, is giving us g of x. This thing is squared. So we have a quadratic equation here in x. So factorizing this becomes 4 outside the brackets into x squared minus 4x minus 2x plus 1 is giving us g of x, and this whole thing is to the power 2. So this continues to be 4 into factorizing this quadratic expression is going to give us x minus 1 squared is giving us g of x, and this whole thing is squared. So definitely, to make this whole thing squared, because we want to eliminate this square, we do it this way. This is going to become 2 into x minus 1. this whole thing becomes squared. This becomes g of x. This whole thing is also squared. So definitely, for us to get rid of this square sign, we find the square root on both sides. This square root sign cancels with that. You remain yourself with this becomes g of x, remains with, of course, the square root sign cancels with that square. We remain with 2 into x minus 1, and this means that g of x is equal to 2 into x minus 1, which is the same as 2x minus 2. And if you look into our answers, 2x minus 2 is C. That is the right answer. So that's the second way of looking at this. What values must be excluded from the domain of this quotient f over g if this is divided by that? Or from this quotient whereby the f is, the function f is that and the function g is given by that. So we'll go ahead and factorize this quadratic expression. Now I'm not going to go into the details of factorizing this expression. The assumption is that you know how to factorize quadratic expressions using completing squares, using factorization method, and so on. So after factorizing this quadratic expression, we end up with, in our numerator, we end up with x minus 1 into 3x minus 1. Divide that by 3x squared minus 2. Continue with this, we shall continue it from here. That's going to become x minus 1 into 3x minus 1. Divide that by the bottom. Actually, it's 3x minus 3, not 2. So this common factor here is 3. It's going to become 3 into x squared minus 1. This is the same as saying x minus 1 into 3x minus 1, divide all that by 3, multiply that by x squared minus 1. X squared minus 1 is the same as x squared minus 1 squared. X squared minus 1 squared gives us a difference of 2 squares. And how do we express difference of 2 squares? The identity in this case is going to become 3 into x minus 1 into x plus 1. And definitely this is going to become x minus 1 into 3x minus 1, divide that by 3 into x minus 1 into x plus 1. So our quotient function turns out to be like that. It turns out to be x minus 1 in brackets into 3x minus 1, all that in brackets, divide that by 3 into x minus 1 into x plus 1. Now when you're dealing with quotient functions, remember we said that the denominator is not supposed to be equal to 0. So looking at this, 3 into x minus 1 and x plus 1, which number should we exclude from the values of x, or which value must we exclude from the domain that could make this entire term to become 0? Now of course, if you look at this expression, x minus 1 means that if we make this value of x a positive 1, this will give us 1 minus 1 giving us a 0, and it makes this whole term 0, so meaning that x should not be 1. Also, if you look at this term, if we make this value of, if x was negative 1, it would mean that as far as this bracket is concerned, negative 1 plus 1 would make this bracket 0. Making this bracket 0 would make this whole term equal to 0, and that would make the value of this quotient undefined. So to avoid that, to avoid this denominator being equal to 0, it means that x should not be equal to either positive or negative 1. And so meaning that if we are to go back to our question is asking us to find the values which must be excluded from the domain of the quotient of the functions f and over g. If f of x was that and g of that, the answer is definitely D. X should not be positive or negative 1, so meaning that our answer here is D. So we're having this question that looks related to like question number 3, the one we had done just a while back. It's telling us that if g of x is giving us 3x plus 2 and g of f into x is giving us x, then find f of 2. So we realize that this is a composite function where any value of x here that is put here is going to be equal to x. So meaning that if we have our value of x here as 1, this thing is 1. If this is 2, the value of x here is 2 in the function f, it means that the overall is 2. If it is 3, it is 3 there, and so on. So again, what we do, we shall start with our original expression. This is a composite function where g is the one outside, and we are having the function f inside the function g. The function g of x is given by 3x plus 2, so it is g into x is given by 3x plus 2. Now, when we put in the place of x, that is inside the function, we put there f of x. So in the place of x, we are going to put this expression f of x. So g into the other function f of x is still going to give us 3. Now in the place of x, we put that function f of x. So it's going to be 3 into the brackets f of x, like that, plus 2. So this is going to become g. Now g of f of x, remember right here, it has given us the impression that g f of x is equivalent to x. So it means that g of f of x in this case is x. So we shall put x here. Is going to give us this expression. Of course, this expression is going to be 3 times f of x plus 2. So we go ahead and make f of x the subject of the formula, because we want f of x first, then we shall put in the value of 2 later. So f of x, the expression is going to become x, making this the subject of the formula means this is going to become x minus 2, divide that by 3, is going to give us f of x. So meaning that the function f where x is the input is giving us x minus 2, divide that by 3. But now the question requires us to find the value of f where the input is 2. So we shall do exactly that here. So meaning that f where the input is 2 is going to give us 2 minus 2 over 3, and this is going to give us 0. So from our objectives here, the answer is A. So in this question, they are telling us that if the function p where x is the input is given by 4x minus 6, and p where the input is a is equal to 0, then what is the value of a? Of course, the value of a here they're telling us that when in the place of x, when we put a in the place of x, the overall expression, the overall function is 0. So we'll begin by quoting the original expression p of x. P of x, or the function of p where x is the input variable, is given by 4x minus 6. So where x is a, meaning that when our function p is such that the value of x is a, given by 4 times value of x where there is x is where we put a, so it's going to become 4a minus 6. Of course, where a is, this p of a is equal to 0. So this thing is equal to 0 is going to give us 4a minus 6. So go ahead and find the value of a. This is going to become 4a being equal to positive 6. When we divide both sides by 4, we shall end up with our value of a as 3 over 2. So our value of a is 3 over 2, and that makes C the answer. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.